So, happy final day of February. In case you've never noticed this about February, because February is a perfect 4 weeks, what does that make happen?
I don't know.
Math. The first, it's divisible.
It's
Caleb,
invisible.
please take off the goggles.
Yes, sir.
So you look at the calendar. You look at the calendar.
Is it
Check
not
this
the-
out, because if you've never noticed it, it's pretty cool. Today is Tuesday the 28th, right?
Yeah.
In March, there will also be Tuesday the 28th.
Oh, weird.
The only months that, like neighboring months that have the same date and day combinations are February and March. Because February has no leftover days after the perfect 4 weeks. So we start March on the same day, like Wednesday, like day of the week, that we started February. So there's kind of a cool relationship that happens. The days and dates of February will always, unless it's a leap year, be the same day date as March. So it's kind of interesting there.
So you
So,
have the probability.
we are going to dive into probability. Now, we know a lot about this already, so we are going to go through the first couple sections probably kind of quickly so that we can get to some of the more complex work. So, if we look at an old clock in your attic, the hour hand is broken off. Sad day. Between noon and 2, how many positions are possible for the hour hand? For a 12-hour period, how many positions are possible? And what's the probability that the clock stopped sometime between 12 and 2? So ponder that as we go through this. We're probably going to come back to this question. But between 12 and 2, how many positions are possible for the hour hand? For a 12-hour period, how many positions are available? And then what's the probability that the hand stopped at some point between the two of them? Actually, we might as well think about this now since your brain's already kind of tuned into it.
I don't get it.
So, think about a clock, right? Hour hand versus minute hand. Which actually, this was a math counts problem. What is the third, I forget what they call it, the third hand on a clock called? The second hand. So,
I would have said the hour hand.
that's hours, minutes, then seconds. Because some clocks don't have second hands. You don't need it.
Well, I go second, minute, hour.
Well, that's just reverse accuracy. You normally start with broadest to narrowest. Lynn, did you have a question? There's somebody had a hand up.
Yeah. So between 12 and 2, wouldn't there be 3 positions available, assuming that it lands on the perfect number?
So you're thinking at noon, at 1, and at 2, right?
Yeah.
Would be
So-
at.
Hmm?
It would be at. It's the mid hand. That's out.
Well, I mean, technically it could be like in any spot, but I'm assuming we're not talking about that.
Well, so that's the hard thing.
That would be
You
impossible.
lose-
That would be
you
an
lose
infinity
every
of
minute.
positions.
So hold on.
Oh, wait.
Depending on the amount of accuracy we decide to take, there really could be infinitely many. So we have to decide how we're going to talk about our accuracy. Well,
Wouldn't it be none because the hour hand broke off? So it can't
So-
be in any positions?
okay. In
No,
general,
how
what I'm
would
saying
outsmart
is
the
in
system,
general. Like,
right?
if so, these two questions are trying to build us to being able to talk about the probability of this question. What's the probability that the clock stops sometime between 12 and noon? Because what it's trying to get us to get to is that probability is calculated by what we want, whatever situation we're looking at, over all of the possible outcomes. So if we talk about between, ooh, that's way off. Noon and 2, or midnight and 2, if we're just talking 12 hours, choose AM, PM, doesn't matter. Now, it's between, it can include noon and 2. So, yeah, like Lynn said, we could have, if we just want to talk about hour notation, it's either in the 12 o'clock hour or in the 1 o'clock hour. Now, that's the question is at the 2, is it still on the end of the 1 o'clock hour or is it starting the 2 o'clock hour? So if we just want to talk about this portion of my clock, we really have two sections. We have the 12 o'clock hour, the 1 o'clock hour. So if we don't want to be too terribly accurate, we can really talk about there being two positions, right? It's between 12 and 1 or between 1 and 2. We could go, as Lynn said, infinitesimally accurate if we talk about it could be at 12:01. It could be at 12:02. The hour hand does move, whatever, so slightly. But then we're going to have to increase the accuracy of everything that we talk about. So right now, we only talk about there being two sectors here, sections 1 and sections 2. How many sections are there total? 12. So what we want, there are 2 possible sections there. There are 12 possible sections total. We get 1/6, which this is the fun one. Repeats 0.16 forever.
Wouldn't there only be like one position between 1 and 12 where it could be?
So it depends on the amount of accuracy that we're talking about. So wait, wait, ask what you said again. Isn't there one position between?
No, because the hour can't move by itself. It's dictated by the minute.
Right, so if you talk about, there's actually 60 positions here. Right, because for every minute
What it can be, because the minute has on a specific spot.
Right, what are you trying to argue? I'm confused.
There'd only be one position in between 1 and 12 would be. No, 1 and 12, no.
So 12 to 1, you're saying that's one position.
Yeah, there's only one.
Yeah, that's what we said. There's one option there. It's in the 12 o'clock hour. Between 12 and 12:59:59.
No, I know. I thought you were trying to say that we're gonna go like big scale.
No, we could. We could zoom in, but then I would just end up with like 60 and 60 and 60 and 60. So we don't need to zoom in. What I'm saying, we're not arguing. We're saying the same thing. What I'm saying is there's no need to think about the further in viewpoint. Like you're saying the same thing that I'm saying. Because when we simplify, it would come out to be the same. So if you wanted to think about every single minute having a different hour position, you could. But we don't need to. We're saying exactly the same thing. Because when you simplify out, it'll be the same thing. Okay, my smartboard is screwy right now. So sorry if it doesn't capture it. Probability has 2 ways that we talk about it. Experimental and theoretical. So the first thing we talk about here is experimental. What does it mean to be experimental versus being theoretical? What does it mean to have a theory versus to conduct an experiment? Yeah.
Theory is like, it's got a lot of research on it.
So I like what you're saying, except research is kind of hard to talk about here. Theoretical, in this case, is going to be from provided information. So not that we necessarily have to research, we might have information just given to us. So I like it. Theoretical from information that we have. We either researched it or somebody gave it to us or whatever.
I kind of think about it like when you flip a coin, it's a 50% chance of being in one, 10% chance of winning.
Is that experimental or theoretical?
But like that is theoretical.
Okay.
But if you flip the coin and say you get heads twice, that doesn't mean you disprove the theory. It's just that you like that's kind of how I think of it. Like
Yeah.
it could come out differently if you experiment it, but it doesn't mean that the probability is wrong.
Yeah, it means that your experiment had a different outcome than the theoretical probability. The theoretical is based on facts we know. There's 2 sides of the coin. It's fair, which means each side has an even probability, 1 out of 2, 50%. But that doesn't mean that that's what actually happens. Ethan?
This is kind of an unrelated question. It's kind of a weird question. I read somewhere that it's not a 50% chance that you get heads or tails. That it's more likely to get tails,
No.
depending on the weight of the coin.
Okay, maybe. But you'd have to run a vast amount of experiment to prove that. So, Ethan's argument, whatever, I'd be curious to see what you read. Like, if you find it again, send it my way, because maybe I'll post it on Schoology. Ethan's argument is that there's a difference between a coin, and I don't know if I have one readily available. Yeah. And something like this. This is a probability chip, right? It's perfectly the same except for its color. So when I flip this, my probability is 50%. But a coin, if the weight is asymmetrical,
They have it on would differ the weight depending on which side it is.
so it's saying that could slightly manipulate how it falls. But the thing is, how are they doing the test? Are they dropping? Are they flipping? Or because if you flip, it shouldn't really have an effect. Because still think about when it falls. Yeah.
Couldn't you just cut the coin in half and weigh it to find that?
If you could cut perfectly down the middle, and the problem is anytime you cut something, there's wasted mass for the cut. So you need some kind of way to
because
like sawdust. Sawdust is wasted mass. It's mass that you've now lost out of the original object. You now have left. Like if you take a piece of wood and cut it, your two halves do not equal what the whole was because you've lost sawdust. So there was a gap. That's why actually an 8-foot long board is normally actually longer than 8 feet because they want you to be able to cut it a couple times depending on what you're doing. Now sometimes it's perfectly 8 feet because you're using it for a certain application. So that we're not going to bring that into play here. A coin has a 50-50
I was
chance.
just wondering if you actually knew the answer.
I've not read that. I'd be curious to see the article. I'm sure they could make an argument, but we could test it through experimentation. Now we'd have to do it with physical coins, but this is a great time to bring up the law of large numbers. Anyone remember what the law of large numbers tells us? Aside from that, David is the loudest person ever.
Well, we already knew that.
Alright, I still need to change that grade at the end of
Oh, it's
class.
fine.
Remind me, because when I got back here, I was logged out, and then a bunch of things happened, and I haven't gotten on math again.
I have a guess.
Okay.
Is it that the more trials you conduct, the closer you'll get to your theoretical probability?
So this kind of combines what Ethan and Carmen are saying. The law of large numbers. And you should have we've talked about this every year you've had probability. Likely, I just don't know how much you remembered it. Like you said, Carmen, if I flip my coin twice and get both heads, I've now got 100% compared to 0%. But if I continue to add more trials, and I flip a third time or a fourth time, 100 times, 200 times, 1,000 times, 1,000,000 times, I should get closer to the theoretical probability as I do more and more trials. So as my numbers get bigger, as my trials get bigger, I should get closer, my experimental should end up closer to my theoretical. You should play the lottery. Yeah, or you have a non-fair coin.
Wait.
That would not happen. Actually, this is interesting because it was just on the news this morning. Anyone know, because we're talking about probability, this is worth it to bring up. Anyone know what the probability of a perfect bracket is for the NCAA?
Oh, is it like
One in 43 quintillion.
Yeah,
is that
something like that.
64 quintillion.
Close.
We did it in elementary school.
Mr. Morgan
Yeah.
showed it.
Didn't just one person.
So, Warren Buffett,
Take a while to-
really rich guy, right? He's offering there's a few different offers that he has on the table, but one of them is $1 million for life for a perfect bracket. And here's why he's offering that.
Well, I think not all probability gave it. There's a little bit of skill involved.
Yes, but the problem is you can't predict the outcome of the basketball game based on the skill of the players.
Unless you break
Like-
into it again.
Yeah,
You kind of can, but there's always upsets.
One
like,
in
so you can't-
9.2 quintillion.
1 out of 9.2 quintillion.
Oh, it's way over.
Because when you start building your bracket, what are your chances of winning or having the right choice here?
1 in
1 and 2, right? What's the odds of having this choice right?
1 in 8.
Well, first off, the two teams that you had here,
That's 1 in
both had to be right to be a perfect bracket.
1 in 4.
And then you have to win this one here.
So 1 in 8.
Then
Oh no, that'd be one.
these teams have to both be
So
right.
basically an X-Men.
1 in
So
16.
what's not So it is going to be a continual multiplication for each of these probabilities. So we have a half times 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 a half, all the way down every first round pick. Times continuing the multiplication, making your life harder. A quarter times a quarter times a quarter times a quarter times a quarter. Continuing for that round, and so on. And when you get into here, the probability is so small, you're then multiplying by very small values, which makes your whole probability tiny, and that's how we get to the 1 in 9.2 quintillion. I forget how exactly that works. They
Oh yeah, no, they have like
Factor
one slot, and then they play, and then you.
Yeah, I'm not that big into basketball.
Then you
to
have to
know.
take the odds of who those two
Yeah,
players.
So I gotta
are.
talk to the Phoenix staff, but I think we did it last year. I think we'll probably do another bracket tournament. I think so. We'll probably do another bracket tournament. We'll look at what the probability
I've
is.
seen
If one of us
video
gets
numbers.
perfect bracket,
I heard somewhere that like this one old lady got a perfect bracket by just guessing based on the mascot she liked.
I don't know that anyone's ever gotten a perfect.
there's like
She might have gotten like the Final Four right, or she might have picked the right winning team, but other teams out of the middle, probably she had wrong picks there. And you can have wrong picks out in your bracket and still end up with the right teams in the middle, but you wouldn't have a perfect bracket because you messed up some of the previous games. But then somehow the teams still made their way to the end.
How would you submit a bracket to the dude to win the $1 million?
I don't know. Read up on it.
Alright.
Yeah, there's a bunch of articles on it. I heard that on the way in this morning on the radio, and I thought that was funny because I was like, wait, did they just say quintillion? We're talking millions, billions, trillions, quadrillions, quintillion.
That's like 15 zeros.
That's 18 digits of.
I've seen video
so he said
numbers.
1
So-
million per your entire life.
Per year.
Oh,
He had on the table $1 billion with a B dollar offer for any of the employees that chose the perfect bracket every single selection. But now he's changed it to be easier. I don't think you have to have a perfect bracket now to win the $1 million. And then he's also offering $100,000 to whoever that works for him that goes the furthest. He's just trying to give away money essentially. Warren Buffett is one of the richest men. in America.
wait, how old is he? Like,
I'm not read up on it. I just heard a blip on the radio.
Because if it's
So,
all 13,
moving on.
I'm fine.
Probability of the complements, which is really funny when we talk about this. So what's the probability of not having a perfect bracket?
A lot more.
Well, it's every single option, the 9.2 quintillion, minus 1 over the 9.2 quintillion. So the probability of the probability of your complement is just 1 minus whatever probability you have. So the probability of the event happening and the probability of the event not happening must sum to 1. So most often, we just take the 1 minus the event to find out the not, or the complement. Any questions? Try to capture this. It might be there. So, we are checking computer systems, LCD monitors to be specific. We find 3 of them to be defective. What is our experimental probability that any monitor would be defective? 3 out of 500. So we set up the event, so P of our event will equal the defect overall. We get 3 over 500, which would be 6 over 1,000. They're okay. If I unsimplify this, it's actually easier. Because if I make this 6 over 1,000, then I can just write it as 6 in the thousandths place. Sorry that my smartboard is broken. So my probability we always normally talk about as a fraction between 0 and 1, but we can communicate it as a percentage, but then we'd always say the percent chance. Probability is dealing with fractions and ratios. So here, our percent chance would be a 0.6%. So under a 1% chance that there'd be a defect. Well, that makes sense. because 5 out of 500 would have been a percent. Because that's like 1 out of 100. So we know this works out because we have all the math. Try B. Huh?
Why is it 0.6 and not 0.0?
Because when we convert to percent, we move our decimal 2 places. Because we multiply by 100
Why do we do that?
to convert to percent form. To
Oh,
go
okay.
decimal, this is back like 7th grade stuff. This is why you haven't done much of this
No, I just
recently.
didn't pay attention.
To go decimal to percent, we multiply by 100. We go percent to decimal. The word percent means divide by 100. Literally what percent means for every 100.
Okay.
So when we do the opposite, we're multiplying by 100.
Okay.
Alright, I'm going to try to reorient this one more time. Try B on your own. I've done this 3 times today. So now we've got a bit more information. If we now know how many they produce, so we now know they produce 15,240 monitors every month. How many of them would we expect to be defective? So to make our prediction here, you might want to write this down as like a formula somewhere. If you do not remember this from our previous courses, to make a prediction, all we want to do is take the probability that we know and multiply it by the population that we're working with. So we determined our probability from a sample. This actually relates back to statistics. We take a sample and we can find some data. Statistics and probability are like, I don't know that I'd say brother and sister, they're very close cousins. So that was determined from our sample of 500 monitors, and we got 0.06, or we could have reduced the 3/500ths to something. It would not have been that great. So our population here, 15,240. What'd you guys get?
91.
Sorry, 0.006. I did not have enough zeros. Thank you, Michelle.
Well, it wouldn't be 0.44 because you can't have 0.44.
Yeah, I just rounded it up to 91 because, well, actually, technically it'd be 92 then.
No, because 0.44 is closer to 91.
No, but if you're assuming that you want, like, if you're
What's the physical number?
91.44 are what you get.
But it's asking for how many are likely to have a defect.
So then would you assume 92? You want to overestimate instead of
Yeah,
underestimate.
it's a physical thing.
No, it'd still be down because it's still more likely to be 91.
Right.
This is one of those situations where there's not a right or wrong answer based on what your math teacher tells you. That would be situational. So we could say 91 to 92. We're approximating around there, in that range. Normally, unless told otherwise, follow the rounding rules. So if this were like some formal test and you had to decide an answer, I would go with 91. Because 0.44, according to our rounding rules, rounds down. Now if we're talking like a situation where we're talking finance or something else where we, like a whole number will make sense, like buying cases of something, or people, like that's different. You gotta round to a whole, so if I'm buying cases and I get 91.4, I really gotta buy 92.
Or like jugs of something.
Yeah, like physical, tangible, real objects. Alright, try this. We want to compute the whole thing out. Find your probability based on your sample, then compute out the prediction based on that. cards in here in a long time. Well, there's just so few of you. I can only just kind of in my head try to make sure I'm talking to those people. Where is Emma?
I think it was in Florida.
I wish I hadn't asked. So then when you look at finding your probability from that sample, what data did we have from our sample?
25 over 40.
Yeah, so we have 25 over 40 from what they communicate. I can either leave it a fraction if it's easily reducible, or you can make it a decimal if you want. I see these can both divide by 5, so I could get 5/8. If you remember your decimal rules, that would actually be 0.625. Because every eighth is 125. So that is our sample population, which might as well just use the fraction because it's easy enough to work with. So that's our sample probability times our entire population in the park. 538. Guys, this sort of like probability type work, even dealing with plants, this happens. We had emerald ash borer, which is still an issue in Ohio, which is this beetle that has been killing all the ash trees. And they literally die from the top down. You can watch the trees die. As soon as it's been infected, it pretty much is just dead.
My friend that he cut down 2 trees in his front yard when they had that.
The crew I used to work for had to go through neighborhoods and literally like cut down neighborhoods. And they replanted trees, but the neighborhood said like, hey, these are all going to end up sick. Take them out, replace them. So when we make this prediction, it'll be slightly over half of them. What do you guys, Travel?
336.25, so 336 through 337.
Yep, so if we're saying about, we could leave that rounded down since it's a 0.25 situation. So now, when we go to calculate theoretical probability, I'm used to my screen being messed up, and now that I actually got the orientation right, it's screwing me. So theoretical probability is not based on anything observed. It's based on given fixed data. So when we roll 2 standard number cubes, I wish I would just say die, but it's cube is nice because we know cube has how many sides? 6. So we're assuming they're numbered 1, 2, 3, 4, 5, 6. Standard die. So what's the probability of rolling 2 numbers that add to 7? Well, if I have 2 die that I'm going to have to add, how many options do I have? If you've done much with dice probability, you know this already, but if you don't, we're going to break it down a little bit. Caleb?
Is it 3?
A lot.
Wait,
We're going to add up the 2 die.
to 7.
Dice.
No, what? So, okay, thanks. Each individual die versus dice. But, so, we want to talk about how many total possible outcomes we have.
A lot more than 3. I didn't do that.
If we built an outcome table, I'm coming to it. If we built an outcome table, we have 1 through 6 on the first die, 1 through 6 on the second die.
Punnett squares that we just
Ah, wait, say that again. What do we call these?
did. It's like the Punnett square.
Yeah,
We learned that in science.
good. So this square will really have how many options? 36.
I called it 3.
It was close. There's
Yeah, I
a
was
3
thinking
in
of
there.
something else.
Yeah,
Even though some of them will add up to be the same, they are technically different occurrences. Imagine
You're just salty, you don't like these.
Ooh, the giant die.
this die and this die. A 3-6 is not the same as a 3-6. So a 3-6 is not actually the same as a 3-6. They're 2 different rolls. They add up to the same thing, but they're 2 different rolls. So even though there would be a strip straight down that adds up to the same thing, and these would add up to the same thing, and these would add up to the same thing, and these would add up to the same, they are not the same occurrences. So if you built this table, 1 and 1, you'd get 2. Then 1 and 2, you get 3 and 3. And then 4, 4 and 4. And 5, 5, 5, 5. Like all the so you repeat the added values. I might be building this slightly wrong. But if you actually fill them all in, we get 36 outcomes. A lot of them are the same thing, but they're different outcomes.
Wait, what about 1 and 1?
That was that 2, that original 2. So if you wanted to
What
actually,
if you rolled like 1 on the big die and 1 on the small die, but then you rolled 1 on the small
that
die?
only has one outcome.
That's the same
outcome.
thing.
Oh. Well,
One
So
on both
when
of
the
them.
numbers are the same, it's the same outcome.
okay.
So there's a box in that 1 inch square. There's a box up here that there's only 1 1, and there's a box down here that there's only 1 12. There's only one way to make it. Both of them have to be that.
That's a 2.
Hmm.
Not a 1.
This,
Top
yeah,
left.
that's a 2.
Top left.
Oh,
That's a 2.
sorry. Yes, that's a 2.
You can't roll 2 dice
Sorry,
and make a 1.
these are 1s.
That'd be cool.
Certain games actually do have blank sides of dice. So that's why this gets.
But
if you
then
can
there
get
wouldn't be a
game
12.
theory-
Game
I'll bring in some of those
theory.
sometime. That's not a cube. So they say standard number cube. So hold up.
Yeah.
Yes,
So-
you could.
Hold on. We need to look at. I might as well just pull this up
You might
because
as
it will
well.
be quicker. We need to look at the outcome table. We can either build one. Or check for one. So this. Yeah, good enough. I like this. Oh, I wish it was. Let's make it. We need to talk about which of these add to. What are we looking for? 7. So actually, funny enough, 7. Who played Catan last year?
Oh, I did.
Game
No, I didn't.
class.
No, I didn't.
7 in Catan does something very special. Moves the feet.
Yeah.
Why does a 7 do that? Why did the game get made like that? Correct. Sure.
On a dice, there's one on the opposite sides. They add up to 7, like 1 and 6, 5 and 2, 3 and 4.
Well,
Why
there's
is
something besides that. 7's the most common roll.
Hey, I was ready. It was 6 day and I called it.
No, you didn't.
I
7 is the most common outcome when rolling 2 die. Because there are so many ways. Hey, Caleb, can you stop talking at the same time as me? Sorry. There are so many ways to make this. The next layer up, these are all the same sums of 6, but you have one less option to make them. These are all a sum of 8, but you have one less option to make them. All the way up to where you only have one way to make a 12, or one way to make a 2. So when we look at the probability of 7, rolling a 7, how many times can that event happen?
I just had a question.
Yeah.
Do you prefer even or odd numbers?
It depends on what I'm doing. Really, I'm not joking.
No, like you just have to choose a favorite. Like,
Okay, then I have to choose favorite odds because they're more interesting.
oh,
And I really like
No.
primes.
Yes, prime numbers are the
Primes
best.
are more fun than anything.
I like odd also.
And,
So I have to
irrational
default to odd only because I like primes, and primes end up odd because they're primes. So, but depending on the situation, I like when things work out to become even numbers because it makes them look nice and like the partners.
even numbers.
Back to our notes. That was a very odd question.
Ah, got you.
Why are you
I don't
so
even think she heard
to
you.
me?
I said that was a very odd question.
Leave your own classroom.
We'll just have a little.
Our event that we want is 7. Please familiarize yourself with how we write our probabilities. We write P, and then in the parentheses goes the event that we're looking for. So the number of times that can occur goes on top, and the bottom is all the total. How many times can it occur? 6.
6.
Out of, which reduces.
1 6.
So you can leave it as 1 6. If you're asked for probability, you're fine to be done there. Or it's 0.1 with the 6 repeating forever, which is approximately 17% if I make these squigglies. Any questions on that? So, using the pundit table is a very good way to shortcut. I want adding to 9. So go check. Outcomes that add to 9. Well, none of those do me any good. Here I'm adding to 7, adding to 8. Ooh, okay. Now we can add, this adds to 9, adds to 9, adds to 9, adds to 9. We get 4 possible outcomes there. That would add us to 9. So probability of 9 is 4 out of 36, which is 1/9, which as decimal form would be,
Point a lot of 11s.
actually it's a lot of 1s.
What's the difference?
So it becomes approximately 11%. Any questions, Brian?
Oh, so when we were in elementary school, my teacher told me that 0.9 repeating is equal to 1.
Yes.
There's certain proofs where you can
Yes,
get.
it is.
Fine. We're not taking more time to go off on tangents today. Sorry, good try.
Marbles.
Didn't we already talk about that at one point?
Yeah, I remember.
Yeah.
Yeah, we talked about that proof.
We did? No, we talked about how
1/3 is
Yeah.
better to use than 0.3 repeated.
Well, that has.
Because technically
Yeah.
it's more
He
accurate.
lost his marbles.
So, we're not going deep into that right now. What's the probability that a random marble is not green? There are 2 ways we can do this, but we would like to solve it as a complement. The easiest way to do this is first find the probability of green.
Yeah, I know how to do it.
So, how do we do it?
Fuse all of them together.
Okay, if I fuse them all together, how many total outcomes are there?
29.
Sure, I'm not going to add and check it, or can somebody verify?
29.
3, 8,
And
5,
then put
yeah.
8 over 29.
Okay,
That's the
so
probability of getting green.
of green is 8 over
And then you
29.
subtract 29 from 8 from 29.
So,
21 over
probability of not green.
I don't know. We used it as
I know,
a science
ironic.
son.
Is 1 minus the probability of green,
Oh yes.
which is 8/29ths. So we don't even have to do anything with this, because I can just leave that as a fraction. I can come here and say, okay, well, what's the complementary fraction? 21/29ths.
Yeah.
That I could then leave, because that probability, that can be your answer.
Right.
Or convert to a decimal.
Which is
Maybe
no one.
a
knew
little
it.
under 3, or a little.
I want to solve it. No one else did. Oh, okay. I see how it is.
Well, approximately 72%.
I even called it.
So, by law, probability on games of chance, like scratch-off tickets,
Oh, I
things
love
like that, must be printed. So, like on a lottery ticket, I won the lottery.
You did?
Yeah.
How much?
The odds of winning are right on the top. They're printed 1 out of. And I should have bought different denominations of tickets. I ran out of cash.
I can't see.
Actually, I barely ever carry any cash. So this probability, what's your odds of winning there?
4.29.
1 out of
Yeah.
4.29. So you have approximately 1 out of 5, or approximately 20% of these tickets printed right below the OH lottery. It tells you the probability right there. But if you continue to read, that says the probability of winning a denomination of 1, 2, 5, 10, and I think it goes up to 75. It is only up to 5,000. But if I win $1 and I paid $1, did I win anything?
No.
So even though I might win, you have a 1/5 chance of winning. They still didn't pay any money when I won my $1. I got my money back.
Oh, that's pretty rad.
So by them incorporating the probability of getting $1 they can jack their probability way higher than what it actually is that you will win money. So this is not the probability that you gain money. That's the probability that you either get your money back or gain money, which is really fun.
That's different for all different like lottery tickets.
Every different ticket. Yeah, most of the like lame-o $1, $2 scratchers are about that probability, are around 1 in 5.
So you can find like the best probability one.
You could buy a bunch and compare which has the best probability, and then that would, in theory, increase your chances of winning. But still, playing games of chance is not good math. Like, I bought that assuming I was going to lose, and I wanted the ticket to show probability at school, and I won. So now I have to go cash that ticket in, or I could keep it and just cost $2 or $2. So I profited $1.
And they can buy another one profit even more.
You're right. So do you let it ride, or
That's
so
not
okay?
gambling.
So
that is
do
illegal.
no, it's not. We have a casino like 15 miles away, man. So, should I, to keep our study of probability going, should I go cash this in and get a $2 ticket, and we compare the probability?
No, because then you're losing $1, and if you
No,
lose,
$2
you're
$1.
down $1.
But I want different than this, because we know the probability of luck of Irish. So I'll try a different ticket and see if they have a
Maybe
different
try luck of
probability.
India.
Buy like $20.
No, I don't want to throw away $20.
You win like $2 million.
Yeah, and then you're gonna argue that I need to split it with you.
Yeah, you do.
Actually, I think you should give me $100,000.
I am more than happy to do that, Stratford. As soon as you give me a million.
No, I'm good.
I will give you $100,000 as soon as you give me a million.
No, I'm good.
Alright, try the got it.
Yeah.
Try the got it for not red. Not red. If you pay attention, we're using the same jar of marbles.
So basically, it's just that.
No, this is doing it right.
So figure out first your probability of red. How many red are there? How many total? So my probability of not
0.655172438.
66%.
0.655172438.
Equal number.
any other questions.
Hey, Mr. Hudson.
If we had really moved at a good clip, we probably could have. Clip with how fast you're going.
You said clip and flip.
Pass them back.
Clip.
Oh, Mr.
Pass
Hudson.
them back, please. Yes, sir.
They sound
My favorite thing is that cable games. My dad always says that if you ever want to make a lot of money, play cable games.
Okay.
Because there's since he's the HR at one of those places,
Yeah.
his main thing is that he has to like fire people for helping people count cards.
What?
Yeah, like he has to fire like employees.
Yeah, because they like their friend comes in and they're not smart enough to count cards on their own.
He's fired at least 30 people for doing meth at work.
And counting cards is not illegal.
No, but they kick you out.
Yeah, they can kick you out because it's private establishment.
Can they take the money you've already earned?
Yes.
No.
That is a great.
Mr. Hudson,